Okay, 2.6, solving absolute value inequalities. So the good news is it's really very, very, very similar to the solving absolute value equations. So remind you of the steps. We're going to get the absolute value by itself. We're going to check for no solution. Here's a difference though, or all real numbers. So we'll talk about that in a minute. And then you're going to write two inequalities. And just like in equations, one positive and one negative. But we're going to, on the negative one, flip the inequality. So I'll show you that when we go through an example, but very, very similar to the ones that we've been doing. Let me back up here. So on step number 2, remember this is going to be absolute value, and then greater than or less than doesn't matter, but we're going to have a negative number over here. So it's the same as okay, so let's do a simple one. Hopefully a simple one. Okay, so get the absolute value by itself. Add the 4 over. Okay, check for no solution or all real numbers. The equations, we're looking for a negative number where the 12 is. Excuse me. So since there's not, we can keep going. So we're going to write our two inequalities. But on the second one, we have to flip from greater than or less than to greater than. It doesn't matter which one it starts with. And then negative 12. Okay, so notice we have greater than, and then we flipped it to less than. Super important. Okay, now solve it like normal. And then on these, we need to graph the solution. So negative 15 is over here, 9 is over here. So it says greater than and equals, so that means I color the circle in. Greater than means go to the right. And then and equal on the 15 also. Less than means go to the left. Okay, so this is an OR problem like we talked about yesterday. So the complete answer is that. Okay, so the solving, like nothing changes from doing equations. Just the graph and so forth on the answer is a little bit different. Okay, let's look at another one. Excuse me. So a couple things here. Get the absolute value by itself. So remember, we always divide by the number that's in the front. Okay, two things. Number one, since we're dealing with greater thans and less thans, if I divide by a negative, I have to turn around the inequality. Okay, because we divided by a negative number. Make that a little bit clearer. Okay, divide by a negative number. All right, so now step 2 is check for no solution or all real numbers, and it's when we have this negative number here. Okay, so remember that at the end, absolute value is always positive. So if I plug in a number for x and I do -4, whatever number I want, I do -4, whatever the answer is, if it's negative, I have to make it positive. If it's positive, then it just stays positive. So no matter what, this is going to be a positive number that comes out of the absolute value. Okay, and so when we look at this one, no matter what, this positive number is going to be greater than -5 every single time, no matter what. Okay, so this one, the answer is all real numbers. Okay, again, because a positive number is always greater than -5. Or any negative number, but in this case, -5. Okay, so if I change the problem just slightly, okay, so if I divide by 2, I don't have to turn around the sign this time because I divided by a positive number, but I'm still here with this -5 thing. So remember, again, this is going to be a positive number. Is a positive number less than, I don't know why I put 15. Is a positive number less than -5? No. So this one is no solution. Okay, and again, because a positive number is never less than a negative number. So all the solving and everything is the same, except for, you got to remember to turn around the inequality if you divide by a negative, but otherwise everything's the same. Let me show you one more. So let's say, I'll do a simple one. Okay, so the absolute value is by itself. It's not no solution or anything because the 8 is positive, not negative. So we write two inequalities. Remember to flip the second one. Was less than, now it's greater than. Okay, so when I go to solve, x is less than 11 on that one. Oh, I forgot to make it negative 8. Going a little bit too fast. So plus 3. So when I go to do a number line, negative 5 is over here. 11's over here. They're both just less than or greater than. They're not and equal, but so I don't color in the circles. So this one says less than 11 means go this way. Greater than negative 5 means go this way. So I end up shading in the middle. So this is an and problem because it's shaded in the middle. And so I just combine the two things together. So if you notice, to write this compound inequality, I just bring these two numbers down. And then the inequality symbols will always point to the left. But if you look at back up here, the x is less than 11. Well, that looks the same down in the answer. And then greater than negative 5, it points at the negative 5, so it's pointing at the negative 5. Okay? So again, nothing's different in terms of the process. You know, the numbers are different, and you got to remember to, if you divide by a negative, to turn the sign around, the inequality around. So you got to remember the stuff for inequalities, but the process is still the same as we did when we did equations. Okay? So most of the problems are fairly straightforward. There's not really any that are super involved. There's a couple toward the end, but most of them are pretty straightforward. Okay? All right. Good luck, guys. We'll see you tomorrow.